Okay, welcome to the third and final part of our demo session. Glad you made it all the way here. In the previous two sessions, we have shown how a model can be developed through a series of experimentations and how it can subsequently be turned into a machine learning product that is 24/7 responding to incoming requests. Now that we have this machine learning product in the air, we can start using it to score credit scoring applications streaming from the operational systems of a bank. Or at least this is how it would be in real life. In this demo, however, we do not have all the operational systems in place, so we simulate them. What you see in front of you is a small simulation controller that is mimicking the behavior of these operational systems and the real world behind them. Practically speaking, this controller generates roughly 500 credit applications per day and sends them to our credit scoring model app that is deployed in Kubernetes. One day in our simulation exercise will be represented by roughly 10 seconds of the real world time. So we are basically fast forwarding here. So let me start the simulation exercise now. Another point to mention is that in the world of operating real-time models, monitoring them also in the real time is crucial. For real-time monitoring of our credit scoring machine learning product, I created a simple Kibana dashboard. I would like to mention that Kibana is not part of Kubeflow. To keep things simple, in my monitoring dashboard, I'm focusing now only on one metric, and that's the population stability index. The population stability index is a well-known model performance metric for credit risk modelers, and it is basically just a metric that tells us how similar the distribution of scores in the population on which the model has been trained is compared to distribution of scores produced by the current population that is flowing through the model. So to put it simple, if these two histograms are similar or comparable, then it means that the distribution of scores coming from the training is similar to the one coming from the real-time data that are flowing to the model as we speak. And then the PSI is quite low, as you can see. We are here in the green light. However, if you introduce a shock, and this could be Corona or financial crisis, that will change the data generating process, the model, the data that are now flowing to the model are shocked, and the PSI start to increase. And high PSI signals that model is producing scores that are, in terms of statistical distribution, quite different than what it was trained on, or simply put, that the model is outdated and biased. And you can see on day 8, I introduced the shock, and I can immediately see increase in the PSI. And this is also a signal that the model should be retrained. Let me pause the simulator for the time being. So we are now in a situation that we have a real-time app. The times have changed. The market is different. We can clearly see from the PSI that the model is no longer fit very well for the data that is receiving. In times like these, a well-engineered process workflow comes handy, because as we shown in the previous two demos, you can go back to your training pipeline. You can launch a new one. You can create a run. I'll again choose the experiment for the webinar. And I can just change my bucketing structure to reflect the change in the data. You see that, for instance, the buckets for duration are now larger. And I can start my training experiment and retrain my model. Once the model is retrained, I can check the outputs. So I have the AUC of 0.79 again. So the model is refreshed for the stressed data. I can go back to the artifacts and I can check what is the model version. So it's here. I can just simply copy the model version. And I will streamline it here a bit, so jump through a couple of steps or skip a couple of steps, and I will directly jump to the scoring, to the fairing part, where I'm going to just change the model versions here, and here is an input. There we go, and I will run my fairing deployment. So you see the new model is being deployed, and I'm waiting for the prediction endpoint. And this is really happening in real time now. So it took me maybe a minute to redo the entire process. In the real world, these kind of redeployments can take weeks or months even. And you can imagine that if the process takes weeks or months, during that period, when your old model is still in process and it's scoring the new application in a biased way, you can accumulate a significant loss. So this really has economic implications in the end of the day. But now I have my prediction endpoint ready, so I can just switch back to my controller. I can resume my I can resume my simulation and just switch to the new model. So I will paste it here and run the new model. And from day 14, we should be able to see that the PSI will start declining again. So currently in day 13, we are around 0.2. 0.2 is really a threshold when the model is really bad. So you should change it. This is some kind of a rule of thumb that you can find in the literature. And you can see the progress again. So it increased, and now you see from day 14 we are back to normal. And since this is average, it will take time to bring the number down because there is some memory, but you can see the PSI declining as of day 14. And so yeah, this is really the end of the demo. So to summarize, we've seen how a model can be developed, how it can be deployed, and then we've simulated a real-life example of operations and monitoring of a model, and we've shown what happens when your model is struck by a shock, by an economic crisis or corona, and how you can quickly react and redeploy the model such that you can continue your operations without major issues. So thank you.